All right, you guys. Today we're talking about parallelograms. Nice big word, not so easy to spell. Hopefully you've seen an object kind of like this. So we're going to talk about all the amazing stuff going on in this shape because there's a whole bunch going on. You guys, parallelograms. The reason that it's called a parallelogram is it has two pairs of parallel sides that must be across from each other. So then remember the arrow denotes parallel. I can't put a single arrow here. Then I'd be trying to tell you all three of these are parallel, which isn't true. So I'm going to put a second set of arrows so we have some differentiation there. All right. This is why it's called a parallelogram. All right. Well, if the opposite sides here are parallel, one other thing you got going on is the opposite sides are actually going to be congruent. Remember that dash mark there denotes congruence. So again, I have to have a differentiated set there. The good news is if we knew the measure of this side, then we know the measure of that side. If we had expressions, something like 3x plus 5 over here, if we had x plus 7 on this side, we can set those equal, create an equation, and solve. All right. Additionally, not only are the opposite sides congruent, the opposite angles are going to be congruent. If this was 70 degrees, that would be 70 degrees. If I knew the measure of this angle, I would know the measure of this angle. All right. Additionally, if we had, let's use a color like this. If we had the diagonals, remember, if we connect two vertices that are consecutive or next to each other, that's going to be a side. If we connect two vertices that are not next to each other, this is referred to as a diagonal. All right. Now, this diagonal, if you can kind of tell, is considerably longer than this diagonal. So those diagonals are not going to be equal. But one thing that they are going to do is they are going to cut each other in half. All right. Trying to remember to cut in half. The diagonals bisect each other, which means this piece here will be equal to this piece here. This will be equal to this. All right. So there's a lot going on here. And one last cool little idea. If I knew the measure of one of these angles, I can actually find the measure of all of the angles. Because remember, the angle across is going to be the same measure. We've talked before that the total in here is 360 degrees. If we take 360 degrees and get rid of the amount of degrees we know about, 110 and 110 makes 220. That leaves us with 140 degrees. Since these are the same, we can cut that in half, and we know each of these would be 70. So if we know one angle, we can find them all, but take a look. One cool thing is the angles that are next to each other, all right, that's referred to as consecutive. I just used that word a second ago, all right. The consecutive angles are going to have a relationship. If this is 110, this is 70. They're obviously not equal, but they do add up to 180 degrees. They will be supplementary. All right. So I want you to understand there's a whole bunch of great things going on inside of parallelograms. A lot of congruence and relationship, and we're going to need to use these to develop equations kind of like we talked about here before. Maybe we're talking about two angles that are consecutive, and you would need to know, oh, if they're supplementary, I need to take those two angles and realize that they have to add up to 180 degrees. All of these are potential equations that can come out of this one beautiful situation. All right. And on top of that, we got to take it a little bit further because this is a little bit where it gets confusing. Question is, what's the minimum amount of information that we would need to know in order to know that we have a parallelogram? Well, there are actually 6 ways. Here we have the 6 ways, and I want you to understand what it looks like. All right. If we happen to know that both pairs of opposite sides of a parallel, if both pairs of opposite sides were parallel, remember what that looks like is an arrow. If I knew these 2 sides were parallel, if I knew these 2 sides were parallel, this has to be a parallelogram. If I know I have a parallelogram, then I get all that other good stuff that we just talked about. All right, but you have to know you have a parallelogram first. These are conditions, and these are very important. Okay, if we knew both pairs of opposite sides were congruent, if I knew this side and this side were congruent, if I knew these were congruent, this has to be a parallelogram, and I get all the goodies that come along with it. If both pairs of opposite angles, all right, and does everybody understand? I drew all of these shapes to look like a square because I don't want you to say, we don't want to go by looks. You don't want to look at this situation and say, man, that looks like a beautiful parallelogram. I bet it is. We do not want to go by looks. I talk about it all the time in class. If we went by looks, I never would have got a job. So we got to go by what we know. So I drew everything to look like a square, but you don't know that this is a square. We have to go by what do we know. Right now we know it has 4 sides. We can guarantee it's a quadrilateral. That's about as far as we can go. But there's these 6 conditions. If I knew that this angle was congruent to this one, I wouldn't know that I have a parallelogram. But if I knew that this angle was also congruent to this one, then I do. All right. This is the minimum 6 ways to know that you have a parallelogram. I think the first 3 are pretty, that makes sense. All right. Number 4, a little bit different. If one pair of opposite sides, either this pair or that pair, if they were not only parallel, but also congruent, believe it or not, you have a parallelogram. You can't have anything else. It might be more specialized than a parallelogram, but we'll talk about that next time. All right. If I knew that both of the diagonals, remember the diagonal is the line that kind of goes across. Quadrilateral has 2. If I knew that they cut each other in half, if I knew this guy got cut in half and I knew this guy got cut in half, then you're guaranteed to have a parallelogram. And last but not least, if I knew that one angle, any one of these 4, let's just choose a random one. Let's say that this was 50 degrees. Now, obviously, it doesn't look 50 degrees. That's okay. We're not going by what we see. We're going by what we know. But if I happen to know that this angle and the one next to it added up to 180 degrees, so if this was 130 degrees, those add up to 180. All right? But I would need both of the consecutive angles. The other one is down here. The other one that is next to the 50-degree angle. If I knew this much information, obviously we could then track down the 4th angle, and then we'd be leading up to this kind of idea here. We would know that the opposite angles would be equal. All right. So today, the big thing that you should get out of this is a bunch of qualities going on inside of a parallelogram. All right. And you get a lot of that good stuff as long as you can verify you have a parallelogram. Here's the 6 ways to verify you have a parallelogram. All right. I would certainly try and have these accessible in your notes because it's 6 things that you would have to memorize. Or you can just write them